Good. Earlier this week, we talked about something called mean absolute deviation. And if I flip back in my notes really quickly, we talked about it as a way to determine if values, data points that I had seemed like they were maybe too far away from the mean. So when we talked about this on, I believe it was Wednesday, this mean absolute deviation, we said that on average, we would expect most of our data to be probably no more than 2 roughly away from the mean. And so for any points that were farther than that from the mean, their deviation, their distance from the mean was more than 2, we said, hey, we might in a couple days start talking about these points as being what we would call outliers, too far away from where I expect my data to be. So today we're going to continue that discussion. We're going to talk about something called standard deviation. So it's another option to calculate deviation. Unlike that mean absolute deviation, this is not something we're going to be able to calculate by hand. So you're going to need your calculators for this one. Before we get into the calculator side of it and how to get the calculator to give me that standard deviation, I actually want to take a look at a couple of data graphs and actually do a little comparing kind of visually for what we expect for standard deviation. So on page 14, we've got a couple different dot plots here. And for each of them, we're given the mean and the standard deviation. Okay, so what I'm going to do is take a look at what we're seeing with each of these. So for my first graph, this is what we called a bell-shaped graph, right? My data is sort of clumped towards the middle and it tapers off at the end. So it's kind of a flat, like smashed down bell, but it's got that bell shape. And it says my mean is 10 and my standard deviation is 2. Okay. I'm not surprised that the mean is 10 because that's kind of where my data is clustered around and it's kind of in the middle of all of those values that I have. And then I don't really have a way to determine if that standard deviation of 2 seems reasonable or not because this is the first standard deviation that we've looked at. So we'll come back to this idea, but based on what I know about mean, that seems reasonable. Now for graph 2, we've got some bell-shaped data again here, but this time, instead of being pretty flat, my bell's pretty sort of tall and skinny, right? I've got, again, a cluster of data around 10, but this time I have a lot of values that are 10, and then a lot of values that are 9 or 11 right on either side, and then it drops off pretty steeply. Here, my sort of mode of 10 was only 4, and then I tapered down to some 1s. But here, my mode of 10 is much bigger, and then I taper off very quickly to those final values, those extreme values, my minimum and maximum just being 1. Okay, so I've got a very tall bell here. My mean is still 10, which looking at my curve makes sense. Looking at my dot plot, that seems reasonable. But I noticed that my standard deviation for this graph is smaller than my standard deviation from graph 1. So where I had a lot of values that were the same as my mean, and most values that either were the mean or very close to the mean, and very few as I got farther away, that steep sort of slope to my bell, I have a smaller standard deviation than when we had sort of a more gradual slope. Okay, so smaller standard deviation here. Looking at graph 3, I do not have a bell shape here. We've got like exactly the opposite, right? We've got one of those dot plots where I've got a clump of data on the left end and a clump of data on the right end. Very little, it tapers down in the middle. My mean is still 10. That should still make sense. Remember, mean is the same as average, so I'm looking at what's in the middle of these values. The middle of 6 and 14 would be 10, right? So as I'm finding the average, these 6s and 14s sort of, I want to say, cancel each other out. They average to 10. Same with the 7s and the 13s. The middle of them would be 10. They average to 10. So even though I have a lot of values on either end of my graph, my average, my mean, is still 10. But this time our standard deviation has gotten pretty big. Now it's almost 3. Okay? Because my data is clumped at either end, and I don't have a lot in the middle, that standard deviation is greater. Now for graph 4, this one looks kind of silly. I just have a bunch of 10s here. Well, it should make sense that my mean is 10 if my only value is 10. But my standard deviation this time is 0. Remember, standard deviation, just like mean absolute deviation, is measuring how far away from the mean my points are. Okay? That's what we talk about when we mean deviation. How different are these values from the mean? Well, if they're not different at all, right? Every value is 10 and our mean was 10. If they're not different at all, that deviation is going to be 0. And we actually saw that the other day with one of our homework problems. Where'd it go? One of our homework problems. We looked at this at the start of class yesterday. For number 2, on homework from the other night, our mean was 16, and we had some values that were 16. So our deviation there was 0 because there isn't a difference between 16 and 16. They're the same. So some big ideas that we should take away from this. Just like our mean absolute deviation, standard deviation is a measure of the spread of our data. I'm going to jot that down. This is measuring, this is a measure of the spread of data. Specifically, what we're measuring is how far data points are from the mean. That's what we're looking at with standard deviation. Looks at how far data points are from the mean. The more tightly packed our data is around the mean, the smaller my standard deviation will be. And in fact, when all my data points are exactly the mean, our standard deviation is 0. So data grouped tightly around the mean has a small standard deviation. Most of my data is close to the mean. I would expect a small standard deviation. On the other end of the spectrum, if I have a lot of data that is far from the mean, I would expect a large standard deviation. Data, oops, not grouped, spread far from the mean has a large standard deviation. So again, standard deviation is telling me how far my data is spread from the mean. Is it really tightly packed around the mean? Is it mostly far away from the mean? Is it spread pretty evenly? That's what standard deviation is looking at. Questions for me so far? Okay, so let's go ahead and pull out our calculators. And we're going to look at how to actually find standard deviation. So on page 15, we have 6 different dot plots that have organized some data for us. Remember, as we're reading a dot plot, each dot represents a unique value, okay? So for our first dot plot, I've got a 1, a 2, a 3, a 4, a 5, a 6. I've got one of every value up through 10. If I were to look at, for example, dot plot 4, since I have 2 dots over 5, that means I have a 5 and a 5, a 10 and a 10, a 15 and a 15. I've got repeated values, right? Each dot is a unique value. So as I take a look at dot plot 1, I'm going to get out my calculator, and we want to find the mean and the standard deviation for each of our dot plots. So I'm going to pull up my calculator here. You cannot do this on Scratchpad, okay? You have to actually be in a document. So go home if you need to, that home menu, and then we want to add a list and spreadsheet, okay? List and spreadsheet. You cannot do this in Scratchpad. We need a list and spreadsheet. And then once I brought up that spreadsheet page, the first thing I want to do is arrow up to this box that has the A in it. This is the column where I'm going to put all of my information. So I need to give it a name. Okay. It doesn't matter what you name it. You could give it your same name. You could name it, these are the data for dot plot 1. If you want to type that all out, I'm just going to call mine A. You could call it whatever you want. I'm going to call mine A. I'm going to hit enter. I need to give this column a name so that in a few minutes, when I tell my calculator to do those computations for me, I can tell it what data I've given it. Okay? And I need a name for that column in order to do so. And I'm going to come down to this first sort of cell in my spreadsheet right next to the 1. And I'm going to enter all that information from my dot plot. So I had a 1, I had a 2, I had a 3. I'm just going to type all that information from my dot plot. Make sure after you type in each point, including the last number, that you hit enter. I typed in all my information. And then this is just my personal preference. I like to arrow over so my highlighted box is in that next column over. You don't have to, but that's my personal preference. Now I'm going to give you the calculator steps, the menus that you need to navigate through. I'm going to go through this slowly, so if you want to write it down, you can. I would suggest you jot it down. So I'm going to start by hitting that menu key. So I went to menu, and then I'm going to go down to statistics. Then I'm going to go to stat calculations. So I did menu, statistics, stat calculations. And now I want to select one variable statistics. That's that first option out of the big long list, one variable statistics. When I choose one variable statistics, I get this little box that pops up. Our number of lists is just going to be 1, so I'm going to hit enter. It's always just going to be 1. And then I get this new box that pops up. For my first selection here, it says X1 list. That's whatever we named our column. So if you remember what you named it, you can type that in right here. If you forgot what you named it, you can hit this little arrow and it brings you a drop-down menu with everything that's been named in your calculator. So that's just this one thing because I only have this one document open called my list A, so that's what I want to select. We're going to keep our frequency at 1, and I don't need to mess with any of this other stuff. So once I selected the name for my list, I'm going to go ahead and hit OK. I believe you can also hit the Enter key, but I think you have to hit it twice. So after I hit OK, it takes me back to my spreadsheet, but I have all this other stuff over here. Okay. All this other stuff is a whole bunch of statistical calculations that our calculator has just done for us. So I'm going to talk you through the stuff that we're seeing in here. So here, this box that has the X with the line over the top of it, we call that X bar. That's another way to signify the mean. So this X bar, X with the line over the top, is the mean. So our calculator gave us the mean. That's nice because we needed to find the mean anyway. Right? So I'm actually going to jot that down on my paper since we're looking at it. The mean for our first dot plot is 5.5. Okay. This next guy here, I'm not going to go through all of these, but this next guy here with the sort of funky looking E, that's the Greek letter, capital letter sigma. The farther you go in mathematics, the more they like to use Greek letters to represent whatever it is that we're talking about. So this guy right here, sigma, we use to represent sum. So I took a bunch of stuff and added it together. So they actually found the sum of all of our data values. That was 55. So if I needed that sum, I've got it there. So for example, if it didn't give me the mean, I have the sum. So all those points are added together and I could divide by how many I had. But it does give me the mean. We'll skip a couple of these because they're not things that you guys will need for our class or Algebra 2. But if we scroll down to this guy right here, it looks like a silly kind of O, like almost like a cursive O, right? The O with the little tail here. That's another Greek letter. That's actually a lowercase sigma. And we use that to represent standard deviation. So this is the standard deviation. That silly looking O is standard deviation. I want you guys to get in the habit of rounding to at least 2 decimal places. So I'm going to say that my standard deviation is 2.87. Give me at least 2 decimal places and make sure you're careful with your rounding. So there's my standard deviation, the other important thing that I needed for this particular question. But there's a couple more pieces of information that this calculator is going to give you that may be helpful for some other problems that you'll look at. Where we see N here, that's how many values I had, how many data points I had. That was 10. So we had 10 pieces of information here. And then let me scroll down here. Min X is my minimum value for my data set. Now, because we had a dot plot, it was pretty easy to see that minimum value. But if my data was presented as just a list of numbers, not in order, having my calculator pick out that minimum may be pretty nice. And then notice it gives me Q1, right? That first quartile, my calculator gives me. The median, it gives me. Q3 is here, and so is our maximum. So if my data weren't in order, I would have to organize it before I could find any of these things. Your calculator has given it to you. So let's say I needed to make a box plot. I can get all of that important information from this tool on my calculator, which is nice. Questions for me so far? Okay, so I'm going to put my calculator away for just a second. So the 2 key pieces of information I wanted for this particular problem were the mean and the standard deviation. Okay. Now we're going to do this again. Let's take a look at dot plot number 3. Now remember, each dot is a unique piece of information. So since I have 2 dots over 10, that means I have 2 values of 10. And then I have 2 values of 20. And then I have 2 30s, 2 40s, 2 50s. Okay. So as I go to enter this information in my calculator, I need to make sure if I see it multiple times that I type it multiple times. Okay. I have to type a 10 for every dot I have over 10. So I'm going to go back to my calculator. And I have a couple options at this point for entering that new information. I could go back to my home screen, make a whole new document on the list and spreadsheet, start from scratch, like we did for this problem. That's fine. I could also just arrow over to a blank column, type a new name up here. So since I called my first list A, I could call the next list B, and then do the same thing. Tell my calculator, go through the menus, tell my calculator to find those calculations for my new list. Or I can go back to the column where I typed my first set of data and just type over it. So I could just replace that data with my new data. You do need to be careful if you're just going to replace your old data. Let's say my old data was a little bit longer than my new data, and I had extra stuff down here that I wanted to get rid of. I have to delete from the bottom up. If I start deleting after my last point here, and there's still things below, it doesn't completely empty the cell. I get this little underscore mark, okay? That guy right there, that causes problems for me when I try to do my calculations. So if you have to get rid of stuff, your old data, you had more of it than your new data, delete from the bottom up, and you will not have any problems. So here's why I like replacing that old list. Notice that all these values changed as I typed this new information. Everything has changed. It's updated with my new information. So if I took that first 10 and changed it to 500, all these numbers changed again because it updated with my data. So let's put it back to what it's supposed to be. This is nice because then I don't have to go through all those menus again. So it's an option. You don't have to do this. I like to because this updates automatically. So I want my mean and my standard deviation for this new set. Here's my mean. That X bar is my mean. So my mean for this new set is 30. And then if I come down, standard deviation is 14.14. I would like you now to find the mean and the standard deviation for those remaining 4 dot plots. Use your calculator to find the mean and the standard deviation for the remaining 4 dot plots. take a look at what you should have gotten here. So for dot plot 1 and dot plot 2, I want you to notice that we have the same standard deviation. We have different means because we had different values, but those values are spread apart the same way. So we went by ones here, one value for each number from 1 to 10. Same idea here. Our scale is going by ones, and I have one value for each number from -9 to 0. So our mean here is negative. That should make sense since we've got negative values. And since, again, our spread is the same, we have the same standard deviation. For dot plots 3 and 4, these look really similar, but there's an important difference here. My scale here is by tens, right? 10, 20, 30, 40, 50. But for 4, my scale is by fives. So 5, 10, 15, 20. So I have a smaller standard deviation here because my data, even though these dot plots look very similar, my data is actually much more closely grouped because my spread here is only by fives, where my spread here is by 10. And then for 5 and 6, 5 looks really similar to that fourth graph from the last page, right? I have a bunch of the same number. So my mean is going to be that number. And since there is no deviation, right? There's no difference from my values to the mean. My standard deviation here is 0. On the exact opposite end of the spectrum, my values are all either the minimum or the maximum. There is nothing in between. So my mean here is 2, right? That middle value. My average of these would be 2, but my standard deviation is really big because if I'm measuring how far everything is spread from the mean, nothing's at the mean. It's all spread as far as it can be from there. So I have a really big standard deviation here. Questions for me so far? Okay, so one of the ideas that we've talked about a little bit is this idea that standard deviation can clue me in as to whether or not the values I have seem reasonable, if they seem like an accurate representation of what it is I'm trying to measure. So formally, officially, when we talk about statistics, anytime that I have data values that are more than 2 standard deviations from the mean, that's where we start to say, I don't know if this data is really great. So data that are more than 2 standard deviations from the mean are considered outliers. Outliers would be values that are unusually high or low. They're kind of outside that realm of what I would expect. Data that are more than 2 standard deviations from the mean are considered outliers, which means they are unusually high or unusually low. So let's take a look at what this looks like, this 2 standard deviations from the mean. What are we talking about there? So I'm going to flip back to page 14, and I want to look at graph number 1. I want to look at graph number 1 because it has a nice mean and a nice standard deviation. Okay, nice whole numbers. You don't have to mess with any decimals here for this example. So any value that is more than 2 standard deviations from the mean is unusual, is what we're saying. So if I'm looking for a value that seems too high, I'm going to look to see what would be 2 standard deviations from the mean. So I'm going to take my mean, and since we're looking for too high, I'm going to add the standard deviation twice. That would be 2 standard deviations from the mean if I add the standard deviation twice. So this would be 12, 14. That means that 14 is my upper limit for what I'm going to consider reasonable. On the other end of the spectrum, a value that's too low would be something that's more than 2 standard deviations below the mean. So I'm going to take the mean and subtract the standard deviation twice. So that would give me 8, 6. So that means 6 is that sort of bottom value that I'd consider reasonable. Anything out here or out here would be a value that seems too high or a value that seems too low, something unusually high or unusually low. That's what we mean when we say more than 2 standard deviations from the mean. So I take the mean and I add the standard deviation twice, or I take the mean and I subtract it twice. That gives me sort of my acceptable range. Here's why we use 2 standard deviations. If I just go 1 standard deviation from the mean, so 10 minus 2 and then 10 plus 2. In this range right here, 1 standard deviation from the mean, I can typically expect to find about 68% of my data. This is 1 standard deviation. More than half of my data, I would typically expect to find within 1 standard deviation of my mean. If I go out to 2 standard deviations, then this kicks up to 95% of my data. 95%, that's almost everything. For this particular distribution, it was everything. But typically I would expect about 95% of my values of my data to fall within 2 standard deviations. That, again, that's almost everything. So that's why we say anything that falls outside of those 2 standard deviations, we consider unusual. If we were to go out 3 standard deviations, that should scoop up everything. 99.9% of my value should be within 3 standard deviations. For sure, anything that's farther than 3 standard deviations from the mean, we say that value isn't any good. That's a fluke, or I mismeasured, or I have a typo, something crazy happened. Okay. So anything outside of 2, we say is unusual. You guys don't have to memorize these percentages, but I wanted to use them to talk about why we say those values would be too high or too low. Questions for me? Okay. So on page 15, we've got one more problem I want to take a look at, our final question here. So we've got a big list of values here. And we're probably gonna look at what's the mean for this, what's the standard deviation, what are my quartiles. So let's say I'm trying to do those calculations on this data set, and I make a typo, and instead of typing 20, I type 200. Is that gonna mess some things up? Yeah, probably. What we wanna look at is what specifically is impacted when I've got one value that is so far away from all the rest. So is that going to impact our mean? For sure. For my original set, my mean is going to be somewhere around 10. For this new set, way bigger. Okay, way, way, way bigger. What about our median? Remember, median is that middle value once they're in order. Drew, you're saying no. Why no? It's still the same amount of numbers, right? This number's incorrect now, but it's still only one digit, and I'm still following it to the middle. So our median is going to be the same. IQR is based on those quartile numbers, Q1 and Q3. Are those going to change? Remember, our median stays the same because we're looking at following those numbers to the middle. My lower quartile number will be the same. My upper quartile number will be the same. So is that range going to be any different? No, that one will stay the same as well. What about our standard deviation? Would I expect that to change? Yeah, I would. The way our original data was set up, I would have evenly distributed data like we saw with dot plot 1 and dot plot 2 at the top of this page. With this typo, I'm now going to have a lot of data grouped down here and then one point way up here. That's going to impact my standard deviation. Now, what I should still find is that this point is so far away from where the rest of my data is grouped that I would still count it an outlier, but it is going to have an impact on my standard deviation. Okay, that's it for Unit 5. That's everything. So for homework tonight, I want you guys to work on page 16, the very last page of your packet. Have some practice with those same types of problems.